Hello everyone, this is Mohammed Shoaib and I'm gonna give you a brief overview of Windows threads. So to understand Windows threads, we have to firstly understand these following topics. What is a process, process structure, process creation, different types of process, what are advantages and disadvantages of process, then what are threads, uses of threads, difference between threads and a process, and what is meant by multi-threading. Moving on, we have what is a process. Process is nothing but a program in execution. It is also called as a task or a job. A process is a program in execution which states that I can give you an example for this. Here we have Google Chrome. These all are processes 1, 2, 3, 4, 5, 6, 7, 7 processes of Google Chrome, in the sense that 7 tabs of Google Chrome are running simultaneously. This is an example of process in a single program. And several processes share the computer simultaneously, which indicates that it uses the memory simultaneously. Moving on, we have the process structure. When a program is loaded into the memory and it becomes a process, it can be divided into 4 sections. These are the 4 sections: stack, heap, data, and text. The stack indicates the process which contains temporary data such as method, function, parameters, return address, and local variables. Heap is nothing but dynamically locating to a process during its runtime. Text is nothing but current activity represented by the value of the program counter, and the data represents the global and static variables. Global variables are nothing but which are defined outside the function, and static variables are nothing but which are defined inside the function and which keep the memory throughout the program execution. Next up, we have the process creation. So how exactly a process is created? Created as tree of processes, resource sharing, execution. The init process inherits process whose parents have terminated. Coming to created as tree of process. Tree of process indicates a parent and a child process. A child process inherits all the properties of the parent process. The resource sharing, in the sense all, some, or nothing. All the processes, some of the processes, or none of the processes. Execution. Parent and child execute simultaneously. Parents wait for child to terminate, then the parent terminates prior to child process, which continues to execute. And lastly, we have the init process inherits process whose parents have been terminated. Coming to different kinds of process, we have the starting state, then we have the ready state, then we have running state, and the block state. In the starting state, the process starts, then it comes to ready state, where it is waiting to be assigned a process by a processor. Then it is assigned a process by the operating system. It might be interrupted by the CPU scheduler to assign to some other process. If process P1 is busy with a task, then a given task is given to a process P2, and process P3 is in waiting state until process P2 completes its execution. Then we have the running state. Once process is assigned, the process is set to run and the processor executes its instruction. In the waiting state, it moves to waiting state while waiting for a file to become available. If P1 is executing a particular task, then P2 is in waiting state until P1 completes its task. Then the last stage is termination. Next up, we have the advantages and disadvantages of process. Operating system normally protects process from one another. They provide each computation with its own virtual machine, allowing the computations to be independent. The processes can run on different machines, unlike threads that have to run on the same machine. Since process can run on different machines, the operating system takes care of its security. And the biggest disadvantage of process is that it is expensive and it takes up a lot of memory. What are threads and why to use them? Coming to threads, a thread can be defined as a semi-process that has its own thread ID. Thread ID is used to uniquely identify a thread. Stack, which is used for memory purpose, and program counter, which is used to point to a particular location and executes a given piece of code. The other definition is thread is a lightweight process and is a basic unit of CPU utilization that is under the control of a process. So why do we use threads? A process with multiple threads make a great server. For example, printer server. Printer server is nothing but a multiple users can access a single printer at a given instance. Because threads share common data, they do not need and use inter-process communications. Threads are dependent on one another. We can say this by the parent and the child relationship. Because of the very nature, threads can take advantage of multiprocessors. Advantages and disadvantages of threads. Coming to advantages, they are cheaper to create in resource. Threads allow parallel programming. The threads can be executed parallelly, and context switching is much faster when compared to processes. Coming to disadvantages, since they are dependent on each other, if one thread is corrupted, then the whole threading gets affected, and the operating system does not protect one thread from another thread like it does for processes. Each process is protected separately, but in the case of threads, it does not support that format. All the threads have to run on the same machine, while in the processes it can run on the different machines. Next, we have the processes versus threads. Similarities: like processes, threads share CPU and only one thread active running at a time. Each thread runs at a particular time. Like process, threads within a threads within a process execute sequentially. Threads execute sequentially. Like processes, threads can create children, and like processes, if one thread is blocked, another thread can run. Differences: unlike processes, threads are not independent of one another. Unlike processes, all threads can access every address in the task. Threads are assigned to assist one another. They are dependent on each other, and in the case of process, they are different users, but in threading, it is a task of a single system. Next up, we have advantages and disadvantages of threads over multiple process. Advantages: threads are very inexpensive and inexpensive to create and destroy. They are inexpensive to represent. And coming to sharing, threads allow sharing of a lot of resources that cannot be shared in a process. Coming to disadvantages, the major disadvantage is that the kernel is single threaded, and security breaches. Since there is an extensive sharing among threads, there is potential problem of security. Next up, we have the multi-threading. Multi-threading is nothing but executing multiple tasks at a given instance of time. There are three models: many to many, many to one, and one to one. In many to many, we have the user space and kernel space. The kernel thread is nothing but it is slower to create, slower, and it is slower in the sense of creation and managing it. In the user level thread, it is generic and can run on any operating system. In many to many, we have 6 processes which are connected to 6 threads. and the developers can create as many as threads as possible when run in parallel on a multiprocessor machine. This provides best accuracy on the system is blocked. In many to one, we have 6 threads, but many threads are connected to one single thread. When thread makes a system call, the whole process will be blocked. In many to one is used when the system does not support user level threads which is executed by the operating system. Only one thread can access at a time. In one to one, this process is more concurrent than many to one. It supports multiple threads to execute in parallel on microprocessors. In one to one, one thread is connected to one user thread is connected.
Hi, I'm Kaushik with WIUID 916266584, recording this presentation about the window threads and its concepts. Before going to the window threads directly, in today's programming world, multi-threaded has become an imperative part of any programming language, whether it's .NET, Java, or C++. To write highly responsive and scalable applications, you must avail the power of multi-threading programming. Window threads has many advantages over the process. It mainly helps the programmers and developers in many features like TPL, P-Link, and also when troubleshooting the multi-threading applications. TPL is nothing but a task parallel library, is a set of public types and application program interfaces in the system.threading and system.threading.task namespaces. The purpose of TPL is to make developers more productive by simplifying the process of adding parallelism and concurrency to the applications. P-Link is nothing but a process linking of applications. And going to the window threads components, and there are three components that are basic for window threading, and those are thread kernel object, stack, and TEB, or simply task environment block. And we learn about these components in detail. And going to the first component, that is thread kernel objects. Kernel is the main component of any operating system, and it acts as a bridge between the applications and hardware. Kernel provides a layer of abstraction through which the application can interact with hardware. Kernel is a part of an operating system that loads first, and it remains in physical memory. The kernel's primary function is to manage the computer's hardware and resources and allow other programs to run on these resources. And what are the kernel objects? Kernel needs to maintain the data about the resources such as processes, threads, files, and etc. For that, kernel uses the kernel data structures, which are known as kernel objects. Each kernel object is simply a memory block allocated by the kernel and is accessible only to the kernel. First and very basic component of the window threads is a thread kernel object. For every thread in system, operating system creates one thread kernel object. The kernel object is also where the system keeps all the statistical information about the thread. You can see the beside the diagram about the kernel thread object and its components. It consists of stack pointer, instruction pointer, and the CPU register, and other statistical data about the stack base, stack limit, thread environmental block, and priority and waiting time, which is nothing but a waiting thread. And we're going to the further. The second basic component of a thread is a stack. Once the thread kernel object has been created, the system allocates memory, which is used for the thread stack. Every thread got its own stack, which means it is used for the maintaining local variables of the functions and for the passing arguments to the function executing inside a thread. When a function executes, it may add some of its state data to the top of the stack like arguments and local variables. When the function exits, it is responsible for the removing the data from the stack. Apart from that, the thread stack is used to store the location of the function calls in order to return statements to return to the current location. And going to the third component, it's a thread environmental block, or simply TEB. It's another important data structure used by every thread is thread environment block. TEB is a block of the memory allocated and initialized in user mode. That means user mode address space is directly accessible to the application code, and whereas kernel mode address space is not accessible to the application code directly. The TAB consumes one page of the memory. That means 4 KB on 86 bytes and 64 CPUs. And coming to the Windows handle type, it's one of the data type which helps to execute the window threads. And with the help of the handle data type threads execute in a window, kernel objects must be manipulated by the Windows application programming interfaces, and programmers cannot and should not attempt to manipulate these objects directly. Such an arrangement is inconsistent with ideas of data abstraction. While this method is convenient, it can also lead to some confusion. And going to the further and how to create a thread, you can see the sample program to how to create a thread, and this function prototype for the create thread, which creates a window thread that begins execution of the function provided as fourth parameter. This function returns a handle that is used to reference the thread that is created. Since every kernel object has security attributes, the first parameter allows the programmer to specify the security attributes of the thread. The security objects mainly controls which process are to be granted to the access to the object and which are to be denied. A null value sets up the default security for the thread object. And the stack size parameter allows the user to specify the amount of stack space that should be reserved for the thread. A value of 0 here sets the stack size to the default of 1 megabyte. The third parameter, the start address, is a global function declared dword-win APIs. This is a function on which the thread will begin its execution. The threaded function can accept single LP-wide parameter. A value for the thread can be specified in fourth parameter. If the function being threaded accepts more than one parameter, you can encapsulate all the parameters into the single structure. Send the structure as a fourth parameter of the create thread cell and decompose the structure into its components as a part of the first thing done in threaded version of the function. Creation flags allow you to start the thread that is suspended. The default is to start the thread as soon as it has been created by the system. Thread ID is an out parameter that is guaranteed unique for all threads running, but may be reused once particular thread exits. If the create thread function fails to create a thread, it will return the false, and reasons for the failure can be found by calling get last error function. It's a command to know the failures for the creation of the thread. And it always recommended that you check error codes for all the Windows API calls. That means application program interface calls. Going furtherly, and this slide presents the method to clean up after the threads are done, and the process exits thus for you. This is a command to destroy the threads in the program. Going furtherly, and this shows this example program for the window threads. It's a sample program to how to create a thread, and when this program will execute, there may be two possible outcomes. First outcome will be a hello thread is printed on the screen, and the second possible outcome is nothing printed on the screen, and this outcome is more likely than previous. Main thread is a process, and when the process ends, all the threads are cancelled. Thus, if the create thread call returns before the OS has had the time to set up the thread and begin execution, the thread will die a premature death when the process ends. And furtherly, the execution of the program details. Main thread is a process. When process goes, all threads go. Need some method of waiting for a thread to finish. Thank you, and this is the end of the presentation of the window threads. Thank you.